flatness. In order to check the flatness of our cylinder heads and or the deck on the block, this area here is called, usually referred to as the deck or deck height. It's the gasket surface sealing area where the head gasket would go. We're going to use a straight edge. This is a straight edge, or sometimes referred to as a master straight edge. We can see here it has a machine surface. This is nice and flat. We've got to be very careful with this thing not to drop it on the floor and so forth. I mean, it is a machine tool. And in conjunction with that, we will use a feeler gauge. Now, prior to checking for flatness, we got to make sure our gasket surfaces are clean. We get all the old gasket, carbon, and debris and so forth cleaned off of the gasket surfaces. So we have a nice flat surface to work with. So there will be a spec set out by the manufacturer on what is an acceptable warpage, meaning deviation in this surface. What we're going to use today for this cylinder head is 3000. So I have a 3000 feeler gauge. And what we'll do is we'll just go along and see, is there any spot that the feeler gauge can go between the straight edge and the surface of the head. We'll do it in multiple locations. Move this along like this. We really want to check here between the valves and the combustion chamber. That's where the most heat is, so it's the most likely area. It's a thin area of metal. It's the most likely area where we would get a warpage. What do we have here? Got a little bit right there, don't we?
Yeah, that's more than 3,000.
So that is more than 3,000s. So what we need, I think that's because of this bracket or this thermostat housing here is sticking up a little bit, and it was holding our straight edge up. So let's move this down and see now. All right. Nope. So we can see there where I had this over like this, and this housing here on the side of the head was actually holding our straight edge up a little bit and throwing our measurements off. We would do it in multiple locations like that. We'll put it on angles like this and do the same thing. Then we're going to come down here and do it in many locations on down through the head. The manufacturer will tell you exactly how many different locations. The longer the cylinder head, the more areas we have to check. We do have another one of these in the tool room that is longer for things that, if we had a 6-cylinder head or whatever, so possibly. So that's checking cylinder flatness or our gasket flatness area. So with that being said, if it had deviations in it that was greater than spec, we would have to do something. That do something may be it needs to go to a machine shop and have this area resurfaced. Maybe the manufacturer does not allow them to resurface it. Maybe there's not enough material to take off, so it would be a cylinder head replacement. That's going to be manufacturer specific. So we check that. Let's say we had a gasket failure, head gasket failure. We take this down, clean it, we check it. If we didn't check it and there was deviations in here that was too excessive, we could have multiple gasket failures just due to we do not have a good sealing surface. That would also go for the block surface. So we would check these surfaces to make sure they're good and flat.
Couldn't you just clean it up with wire?
Well, you could clean it up, but if there was still deviations like this in it, if there was uneven spots, we're not going to get the acceptable crunch on the gasket that we're looking for when we tighten it down. So that is checking for flatness. Is there any questions on that? Now the next thing we're going to talk about is checking for valve recession. As our valves and seats wear, because this valve is constantly going up and down and smacking against the seat and the sealing surface on the valve here, these valves over time will wear, and as they wear, they go deeper into the cylinder head. So there is a specification on what we call valve recession. Now we typically do not measure this on gas engines. How many of you have a gas engine in this group? Oh, you don't.
Not.
What does your heads look like different than these heads? What's that? They're indented. The combustion chambers on gas heads, usually the valves set down in a bowl or cupped area. So we typically do not measure valve recession on gas engines. Diesel engine heads are usually flat. Okay, so we're going to talk about valve recession.
Wouldn't they have injectors, not valves? Wouldn't diesel engines have injectors too?
Yes.
Not valves?
No, they got to have valves too. We got to let the air in and let the exhaust out, right? Okay. So we're going to measure our valve recession with a depth mic. Now this depth mic's kind of a cheater because it has a digital readout on it. But this depth mic is much like our micrometers with the scale, except for it's backwards. And the micrometer, as we roll the thimble out, we uncover numbers, and that's how we measure it. The depth mic, as we roll it in, it will cover up numbers. If we look at this, the scale's backwards, it'll cover up the numbers, and we need to measure on what is covered. Also, this has a little cheater thing here for a little digital readout that'll tell us what the measurement is. Also with our depth mics, as we have to change distances, we can change the rods inside here, so we can use this depth mic to measure many depths. Unlike our micrometers that we need, they're in inch increments. Okay, so what we do, and especially if we have valves like this that have a recessed area or something in the middle like this, we're not going to measure off that. We're going to measure off this flat surface.
That's what we had on our homework, where it was different.
Yes, it was. So I really quick took a measurement of this valve, and it says 20 thousandths. 20 thousandths is our depth. We would check that against what the specification is. We certainly need to know if it's an intake or exhaust valve. So that's one of them. We can come over to the next valve and do the same thing. And 8 thousandths. Okay, so we have 20 thousandths and 8 thousandths. We check that against the manufacturer specifications to determine, is it correct? If it is correct, we may not have to do anything. If it is not correct, we may have to put new seats in, new valves, to get the measurement back to where it's supposed to be. How might we go about determining which one's an intake and which one's an exhaust valve?
Exhaust. Whatever we call exhaust port.
Okay, so we can look at the intake or exhaust ports. If we're going to look at the intake of the exhaust ports, we better know which is which, right? So, how might we tell the difference between an intake and exhaust port at a glance? What?
Exhaust probably smaller.
I wouldn't go with that.
It takes money on the top.
I wouldn't go with that either.
Exhaust is dirty.
Exhaust is dirty. That's what I would go with. I mean, I'm not going to say that that is a fail-safe because you could have a dirty intake, but typically our exhaust side is going to show some sort of soot. We can see where this is considerably dirtier than this side. These are our intake ports. So on our intake ports, we can follow them in, see what valve they go to. This is our intake port or intake valve on this head. This is our exhaust.
Why are they different shapes?
They're not different shape, they're different sized.
One circle, one square.
Oh, the ports?
Yeah.
It has to do with flow. However, I mean, we will see a lot of different port designs on engines, and it has to do with airflow. How to get air in and how to scavenge the air out of the cylinder after combustion. Different manufacturers, and whether it's turbocharged, non-turbocharged, supercharged, non-supercharged, there's going to be a lot of factors that go into that to determine shape of ports. Most of that's going to be based on the manufacturer's decision. So that's valve recession. Can anybody tell me what these things are here? These little cups?
Exhaust, or those dumps.
I don't know what dumps